How would you partition a graph or train an AI model to identify clusters of similar data? Well, the correct answer is graph theory. Let's start by understanding what is a graph. Imagine you're mapping out your friends on social media. Each friend is a node, and a friendship between them can be represented using an edge. This collection of edges and nodes is called a graph. As our social network expands, keeping track of new connections in a list like manner can get messy. That's where the adjacency matrix comes in. Imagine a table where each row and column represents a person in our social media network. If two people are friends, we put a 1 in that spot. Else, we put a 0. Next, we have the degree matrix. Think of it as a diagonal matrix where each entry represents the number of friendships a node has, also known as the node's degree. Now let's get back to our problem, and by using graph theory, partition this graph into two clusters. We start with the most essential tool called the Laplacian matrix. We create it by subtracting the adjacency matrix from the degree matrix. Think of it as the measure of how chatty someone is in our social media network. This is where things get interesting. We can use advanced math tools called eigenvalues and eigenvectors to unlock the secrets of the Laplacian matrix. These values can be found out simply using the NumPy math library. Here are the calculated values for our graph. Finally, we can partition the graph using some basic concepts. The second smallest eigenvalue and its corresponding eigenvector are called the Fiedler value and the Fiedler vector. In our case, it's the fifth eigenvalue. Now, by sorting the Fiedler vector and finding where the value changes from negative to positive, we can identify the segregation point in the network. In our graph, the segregation point is between node 5 and node 3. Thus, we can form two clusters, one with negative signs and the other with positive. And with this, the clustering problem has been solved.